What's up, Squads? Welcome back. We're talking about functions. Functions is a very important topic because in Algebra 1 and Algebra 2, you learn all these different types of function, but the key important part is understanding the fundamentals of what a function is. So that is your question for today. What is a function? So the definition of a function is for every input, there is exactly one output. I'm underlining keywords. All of this is important. So for every input, there's exactly one output. So what does that mean? Well, input represents your x value, right? Y is your input. How do we do a table? Well, we normally just pick values for x. We input whatever we want, and then we plug that value in for x, and then we solve it, and we get our output, which is your y value. This is the heart of it, because today I'm going to have different examples with different parts. So we're going to talk about defining a function. Is it a function if I tell it graphically? Is it a function if I give you points? Is it a function if I do a mapping? All of those might look different, but the whole fundamental key concept is right here. So for every input, there is exactly one output. That's the most important part. All right, so let's take a couple of examples, because there's different ways to view it. So your first way to view it is, let's look at it during points. So let's say I give you points. All right, so if I give you a couple points like 1, 4, and 2, 5, and 0, 7. Well, if you look at these points, our goal is, by looking at this, is this a function? Well, how do I tell? Well, let's go back to the definition. I'm going to go back to the definition for every problem. So for every input, there's exactly one output. So for every x, there's exactly one y. So that's what we're looking for. So for every x value, is there exactly one y value? In other words, is there any x values that have multiple y values? If not, then this is a function. So if I look at this, 1 only goes to 4, 2 only goes to 5, 0 only goes to 7. So because that's true, so for every input there's exactly one output, this is a function, yes. Right? Let's try another example. Well, what if I look at it through a map? Well, a map is the same thing as looking at points. We're able to derive points by looking at the map. So if I give you a couple numbers here, so I have 0, 1, 2 for x, and 3, 4 for y, and let's say 0 goes to 3, 1 goes to 3, 2 goes to 4, and let's say 1 also goes to 4. Question is this a function? Well, how can we tell? Well, let's go back to the definition. What is a definition? So for every input, there's exactly one output. So for every x, there should only be one y associated to it. Well, is this a function then? What do you guys think? Yes or no? Well, it's not a function because what happens here? How many outputs does this input have? It has more than one. In other words, 1 goes to 3, 1 goes to 4. So because of that, this is not a function. All right. Well, how would this look if I look at it as points? Well, let's write the points out. You have 0, 3, 1, 3, 1, 4, and then 2, 4. Right? I just pretty much make this mapping into points. Well, what happens? Well, for an input should only have one output. Well, in this case, 1 goes to 3 and 1 goes to 4. So because we have that, it is not a function. Don't get confused with the definition, because a lot of kids think, well, for every output, there should only be one input. That's wrong. It only considers that for every input, there's exactly one output. So So a lot of kids might think of, well, there's 2 4s here on my y values, so that's not a function. That is not true. We can actually have that. So we talked about points, talked about mapping. How about graphically? Well, let's say I have a graph, some graph like this. Well, is this a function? Well, how do you tell? Well, for every input, there's exactly one output. So for every input, there's one output. For every input, there's one output. For every input, there's one output. So, is this true? Is this a function? Yes. Because for every input, there's exactly one output. Alright? A rule that we use is called the vertical line test. I don't want you to just use the vertical line test because it's the easy way of using it. I want you to understand why we're using the vertical line test. Why do you guys think we're using the vertical line test? Right? In other words, the vertical line test states that if you have a vertical line, you kind of go through your function, it should only hit one point. So here I hit 1 point, here I hit 1 point, and so forth. But what's the reason why we're using a vertical line test and not some other test? Well, the reason why is because it's back to the definition. So for every input, there's exactly one output. So as I go across my x values here, it should only hit one y value. So as I go through my inputs, there should only be exactly one output. And here you can tell there is exactly one output. All right, so that is what a function is. That's the definition. So once again, for every input, there's exactly one output. Please say it to yourself 100 times so you memorize it, because this is the heart when we start talking about all the other different functions. You will learn all these different functions: linear, quadratic, exponential, rational, radical, trig, and other. There's a bunch more, but those are the main ones that you'll learn in Algebra 1 and Algebra 2. Right? So that concludes our lesson. We're going to do 3 examples like we always do: your beginner, your intermediate, and your advanced level. Let's do it. You guys ready? You guys ready to try this out? So let's try your first problem. If I give you a bunch of points, okay, so I have 4 points. I want you to answer this question. Is this a function? And don't just say yes or no, but please explain why it is a function or why it is not a function. I'm going to give you about 30 seconds to a minute. Try your best. Don't give up. Like I said, we always have to start somewhere. Right now is the time to start. So try your best. Go. Alright, so what is my answer? Yes or no? Well, the definition for every input is exactly one output. So then we have to look at our x values. Do any of them have multiple y values? Yes, here and here. So this 2 goes to 4, and this 2 also goes to 2. Alright, so this is not a function. No. Alright? I don't want you guys to think that, well, there's 2 2's here, so it's not a function. You can have that once again. You just can't have your inputs having multiple outputs. So check your answers, make sure you understand that. Let's move on to our intermediate problem. Let's look at it through a map. So say 1, 2, 3, 4, 5. And then let's do that. So try your best. Same question. Is this map a function? Yes or no, and why? The key important part is why. So if you get confused, think about the definition of what a function is. I'll give you about 30 seconds to a minute. Try your best. Go. So, is this a function? Yes or no? Well, a lot of kids might think, well, this 4 has 2 values. This output has 2 inputs, so it might not be a function. But is that what the definition really is? The definition is what, once again? So for every input, exactly one output. So we don't care about that. So this input at 1 has how many outputs? 1 at 4. How many inputs does 2 have? Or how many outputs does 2 have? Has 1 at 4. How many outputs does 3 have? 1 at 5. So yes, this is a function. All right, so be careful, I'll try to trick you there. So check your answers, and let's move on to our advanced problem. So this is your question. Graph an alphabet that isn't a function and one that is a function. So I need two. I need one that is a function and one that's not. And think to yourself, why and why not is it a function or not? All right, so try your best. You've got 30 seconds to a minute. Let's try your best. Go. All right, there's various answers to this problem. Let's start with what is a function. All right, give me an alphabet that is a function. Well, one could be like a W. If you write it like this, right? If I draw a vertical line test, every input there's exactly one output, so it only intersects at one place. You do M. If you write M like this, that works too. Right? Most of them aren't going to be functions. Like C, is C a function? No, because what happens there? It hits multiple outputs, right? O for sure doesn't work. It might look like it works because over here there's only one output, but then as we just go through it, through our inputs, there's going to be two outputs for many of these cases. So lots of them works, lots of them don't, so try your best. So that concludes our lesson with functions. What is a function? Let's repeat that once again. So for every input, there's exactly what? Good, one output. All right, so hopefully this video helped you. Please subscribe to my channel. Please turn on notifications. Let's get ready for some more videos.